you are joining online classes. So now from today onwards, we are conducting the classes on WebEx. Okay. So everyone has to join with their miss at the time of joining. You mention your roll number also. So that means we will take the attendance directly through WebEx. There is no separate roll call or the chat box that we are going to refer. Okay. So whosoever is going to join the classes, these online classes, so their attendance will be directly taken from the login. Okay. So please try to ensure that your roll number should be mentioned. So that means it will be convenient for us also to know who has joined this classes. Okay. And then second one, TA1, we are going to circulate one notice related to your TA1. So TA1 actually this is your immediately the online has been started. So that's why we could not be able to focus on that TA part. So we are going to conduct this TA in an online form only. So this TA will be your poster presentation, means the poster that you have to prepare. So there is one activity. So this basically this TA we are going to consider at the last, that is as a TA number 3. So only we have changed the manner because of the lockdown. So at least you should be able to familiar about this. Then and only we will focus on TA 2 and 3 syllabus base. Okay. So right now this TA will not be on your syllabus part. So it will be general TA, that is a TA number 3. Going to upload the Google Classroom so that you can be able to upload your this posters. Okay, so you can prepare the poster manually also on your sheet, and you can scan it, and then you can be able to post on your Google Classroom, or you can prepare a digital poster also. Okay, so all the guidelines, rules, regulation that is also been given, and that posters will be miss you will be in a part of competition also. Okay. Okay, so every guidelines are given in the notice. So maybe today you will get that notice related to the TA. Fine. Now we'll move to our syllabus part. So as you know, in last lecture we have revised the entire chapter, that is electron ballistic as well as the electron optics part, and then we came to the conclusion of the next. I think we are stopped over here. Electrostatic lens. So we have stopped at the electrostatic lens, and we are about to start with the CRO, that is cathode ray oscilloscope. So before that, CRT already we have covered, but just to revise CRT once again, those you have missed. So that means we can be able to switch over to the CRO, and then we can be able to complete this unit entirely by today itself. So now to start with the CRT, that is cathode ray tube, as we already discussed, CRT is mainly divided into the three parts. So the first part you can be able to see up to A3, the anode A3, we call this as an electron gun. And then after the A3 anode, there are the two plates. One is Y, another is X plate. So Y and X plate, they form a system that we call as a deflecting system. Okay. And lastly, the screen, that is a fluorescent screen. So these are the main divisions of cathode ray tube. So what are the different parts of this CRT that we have to focus? So CRT, the first part, that is electron gun, which consists of the filament F. You can see here the filament F, which has a separate supply of 6.3 volt. Then this filament, which is covered by the cathode, you can see in the diagram also the filament which is covered by the cathode, and then in front of the cathode there is a grid which has opening part. Okay, so this filament, once it has been when this supply has been on, so filament get heated and it will heat the cathode. So due to this thermal process, the cathode starts emitting the number of electrons, and these passage of electron will be controlled by the grid. So grid which has a particular opening part, and grid is also maintained at certain potential. So you can see here the control, the grid which has been given a supply to the intensity control. So as you know, the intensity means the brightness. So if more number of particles or the electrons will come out, so more will be the intensity. So it should be intense, means you have to make the grid in such a way, the grid potential you have to maintain in such a way so that it should be intense beam. Whichever the beam that is come out, it should be the intense one. Okay, so that is the main purpose or the first part of this CRT, that is filament, cathode and the grid. So these three electrodes, they play a role to generate the collimated beam of electron. Okay, so once the collimated beam of electron will generated, then it will enter into the system of A1, A2 and A3. So you can see here the A1, which is known as the pre-accelerating anode, because you have generated the beam of electron. Now this generated beam of electron has to move forward. So that moving job, which is to be done by the pre-accelerating anode. So these anodes which are held at higher potential, maybe around say 1000 volts also. Okay, so this anode which will try to pull the particle in a forward direction, and then these particles, this electron beam, they will pass out through the anode A2, that is focusing anode, as we have seen in an electrostatic lens. So basically these A1, A2 are these are the cylindrical structure, and they form a electrostatic lens between the gap. So there is a gap between this A1, A2 or A3. So they form an electrostatic lens due to the equipotential surfaces. So the particle can focuses in a anode A2. So therefore A2 is known as the focusing anode. And then after this, lastly the A3, that accelerating anode, which is been used to accelerate the focus beam of electron. Okay, so whichever the beam that will focus in an anode A2, that will be travel further toward the screen. So that job which is to be done by the accelerating anode. Okay, so ultimately if you want to conclude about the electron gun, so electron gun is basically being used for the emission of the electrons, and then it is used, means or if you want to write in a statement form, like you can be able to write, say it is used to generate the electron beam, focuses it and accelerate it toward the fluorescent screen. So this electron beam can be moved horizontally and vertically. Now the next statement will start. So how, means once the electron beam is generated, now this electron beam can be, means horizontally or vertically, or you can say along x or along y direction. We can deflect this electron beam on a screen with the help of deflecting system. So that deflecting system, which has two plates, one is y, another is x plate. So you can elaborate what is y plate and what is x plate. So y means the plates which are placed horizontally, and the electric field which is set up along the y direction. So therefore the particle can deflect along the y direction. So that's when the name is given y plate. And there are the two plates which are placed vertically, and the electric field is set up along the x direction. So they call as a x plate. So particle can deflect along the horizontal direction. So in this way, means the beam of electron which is passing through the system of x and the y plate, and then it will focus on the CRT screen. So CRT screen, you can see the outer surface of the CRT screen, which is coated by the aqueduct material. The aqueduct, as we have discussed, the aqueduct, which is a graphite material, a conducting material, and this a material which is outer surface, which has been internally connected to the anode A3. So that means it can be maintained at the positive potential, so that whichever the secondary emitted electron, means once the beam of electron will struck on the CRT screen, so the inside surface of the CRT screen is coated with a phosphor material, the material which has a property of producing the luminescence, that is a photon energy. So when the photon energy, means you are getting a glow on the screen. So due to this, there is a release of secondary emitted electrons. So secondary electrons get emitted. So these electrons get absorbed by this aqueduct coating. So aqueduct coating basically is being used for absorption of the secondary emitted electrons. Okay. So and then finally it will complete the entire circuit. Circuit, it means a loop, a complete loop which has been done with the help of this aqueduct coating. So this is about the CRT. So CRT is been called as the heart of CRO. So then one more you can be able to see here, there is another control, that is focus control, then astigmatism control. So these controls you can be able to see the highest potential that also mentioned, that is 1350 volt, that is also been assigned to these anodes. And focus control, so focus control you can see is a variable terminal, so that means you can be able to focus the beam on a screen at a particular location. So where exactly we have to focus as per the requirement, so we can be able to focus with the help of this. So these are the controls which are available on the front panel of a CRO, that is intensity control knob as well as the focus control knob. So now we will move to the CRO, that is cathode ray oscilloscope. So this is what we call as the block diagram of CRO, that is cathode ray oscilloscope. So just now we have discussed about the CRT. So CRT, as you can see, and then there are the other parts of the CRO. One is the vertical amplifier, then delay line, then there is the HT and LT. HT is the high tension voltage supply, then low tension voltage supply, then trigger circuit, time based circuit, and the horizontal amplifier. Okay, so these are the main parts. You can label here also the cathode ray tube, time based circuit, trigger circuit, vertical circuit, horizontal circuit, low voltage supply, and the high voltage supply. So we'll refer the diagram once again. So, and it's a dual trace CRO. So dual means there are the two traces. One, you can see there are the two types of input. One is X input, another is the Y input. And there's a switch also. You can see here between the time base and the horizontal amplifier, there is a switch arrangement, so that the switch, if it is toward the internal, so the sweep signal can be given to the horizontal amplifier. If the switch is toward the external terminal, so directly the X input will be given to the horizontal amplifier. So it means how the signal can be terminated to one internal or external, so that can be decided from the switch terminal. So now we'll try to see the role of each and every block. So CRT already I discussed. Now consider the Y input is been given to the vertical amplifier, that is Y here, and the X input is here. So the Y input has been given. So vertical amplifier. So as already we said, the vertical amplifier, which is we can say it consists of the two types of devices. One we can call as a attenuator. Another is the voltage amplifier. So the attenuator means the signal to be tested is amplified at the Y input. So whichever the signal that we have to test, suppose at Y input the signal has been given, and that we need to test. Okay, so that testing job which is to be done by the attenuator as well as the voltage amplifier. So it so first of all, this signal which reaches to the attenuator, and then attenuator verifies the signal strength. If the signal strength is proper, the signal strength means the signal amplitude. So whether the signal amplitude is to be increased or decreased. So if it has to be increased, so that is to be given by the voltage amplifier. And if it has to be decreased, so that suppression job to be done by the attenuator itself. Okay. So the amount of attenuation, and then it has been fed to the input of the voltage amplifier. So that means you can be able to get the adequate deflection on the screen. Okay, so that is the main job of the vertical amplifier. So once again we'll repeat. So vertical amplifier, basically it consists of the attenuator as well as the voltage amplifier. The purpose of this is attenuator means it first check, means it detect the signal, कि whatever the signal is been given. So first it will detect कि whether what is the strength of the signal, whether it is weak or it is strong, means whether the signal has to be increased or it has to be decreased. So if the signal strength is more as expected, so if it is more, so it can be attenuated, means suppress. And if it is low, so it can be given to the voltage amplifier for the amplification purpose. So that job which is to be done by the vertical amplifier, and then this signal which has been given to the Y input, as delay line is been between this. So I will just explain about what exactly the play of role play by the delay line. So before that, we can be able to see here there's a trigger circuit as well as time base and the horizontal amplifier. So horizontal amplifier, that is again we can call as a horizontal circuit. So it also consists of the voltage amplifier, and which is to be means the signal which is to be given, that can be amplified. So when the sweep selector switch is in INT position, when this you can say the switch INT and EXT, these are the two terminals. So when the sweep selector switch is an INT position, the sweep voltage is applied to the horizontal amplifier, and when the sweep selector switch is held in the EXT position, the horizontal amplifier input is disconnected from the internal sweep generator, and the electron beam remains stationary and produces a luminescent spot at the center of the CRO screen. So please try to understand ki what I said, ki here there is a switch arrangement. So when the switch is at the INT and when switch is at the EXT position, so when it is at INT, that is internal, so the sweep voltage is applied to the horizontal amplifier, and when the sweep selector is at the external position EXT, the horizontal amplifier input is disconnected. So it is internal means external signal that we are giving. Okay, so it has been disconnected from the internal, and the electron beam remains stationary because there is no as such the time based direct input from the X that we are giving, and that will be given to the X plate. Okay, so in this way means directly you can be able to get the spot on the center of the CRO screen. So this is a basic difference. So the time based generator means if the signal is been coming from the time base, that will be a sweep signal, and that you can be able to control with the help of the time based knob on a CRO panel. On CRO panel, you will see there is a volt per division knob, one for horizontal amplifier and second one is for the vertical amplifier. So the two means there are two inputs X and Y. So the two are the two traces that you will see on a CRO screen. So these two traces, their amplitudes can be modified with the help of this volt per division knob. Okay, so volt per division, if you are changing, it means you are changing along the Y axis. Okay, and if you are making any changes along X axis, that means your time based circuit, the time base or time per division. Okay, so if any signal which you are getting on a CRO screen, so it follows the axis like along X axis is a time axis and along Y axis is a voltage axis. Okay, so please try to remember volt per division, that is available with the help of vertical as well as the horizontal, means for amplification or attenuation, means both the job we can be able to do, means we can be able to increase or we can be able to decrease the amplitude of the particular waveform that will be given as a signal to the circuitry. Okay, so this is about the voltage amplifier. Then if you move to the trigger circuit, so you can see that trigger circuit basically is being used for the synchronization. So synchronization means what? The synchronization of the signals. So synchronization, it is the method of locking the frequency. So which frequency we can be able to lock with the help of this trigger circuit? So trigger circuit basically is being used for the locking of time base generator. This time base circuit means the whichever the signal which we are coming from the time base, that is a sawtooth or signal sweep signal, we can say the sawtooth. Now why the name is given sawtooth, you can say the arrangement, the waves that look to be like a tip, so that's why it is sawtooth. Okay, so sawtooth, the teeth of a saw. So that's why it is called the sawtooth waveforms. So this waveform which is to be generated from the time base, that also called as a sweep signal. So that if the signal which is coming from the time base and the input signal, if they matches properly, so that matching job or locking job which we call as a synchronization, so they are in a sync. Okay, so that means we can be able to get the stationary pattern on a CRO screen. Stationary means stable. So wherever you have to take the observation, like suppose if you want to measure the amplitude or if you want to find out the phase shift of a particular Lissajous pattern. So how we can be able to get these things, or any sort of a measurement? So you have to count the number of divisions on the CRO screen. So to record all these things, we require a stationary pattern. So how we can able to get this? So that job which is to be done by the trigger circuit. So trigger circuit, once you press that knob, that is a trigger circuit knob. So it means you are matching both the frequency, means the signals. One signal which is coming from the time base, another which is been given in a input form. Okay, so that is called as the synchronization. Okay, So this is the major role that has been played by the trigger circuit. Now you can see this trigger circuit has been connected with the delay line. So this delay line, which is again which equally play a role for the synchronization purpose. So delay, it means if whichever the signal which is coming from say Y input, so there should not be any delay. So that job which is to be handled by the delay line circuit. So that delay line circuit will ensure about if any signal which is coming from the Y input, there should not be a delay for the synchronization. Otherwise, your pattern will not be a stationary one. So that job which is to be done by the delay line. Okay. So this is about, and lastly, as I mentioned about the time base. So time base, you can be able to see the signal that is coming. It is like this. Here is the time base. Uh, it mainly consists of the time based generator. So you know about the generator. Generator basically are the oscillators. So which will generate the frequencies. So basically means if you are getting a signal on the screen, so that is nothing but the frequency which we are generating. So that's why it is called the generator or the oscillators also. There are oscillators which have been used for generating this frequency. So here the time-based generator is a variable frequency generator which produces the ramp voltage. And due to its resemblance to the teeth of saw, it is also called as the sawtooth voltage. You can see the voltage that comes out in a forms a ramp. It's like a ramp. So or it is also called as the sawtooth or sweep signal. So this is about the time base. Now these are the trigger circuits, the signals you can see here. In general here, when F signal and the sweep signal. F signal means the input signal, the frequency of the input signal, which is equals to n times the frequency of the sweep signal. If these conditions has been satisfied, then and only we can say that the signals are in a synchronized manner. So here the different waveforms are being given to satisfy this synchronization job. Okay. So on synchronization, you can be able to see the signals which has been enhanced also. So this is how we can be able to get the stationary patterns on the CRO screen. So here is the detailing of synchronization. What is synchronization? So just we'll read out it. So synchronization is the method of locking the frequency of time-based generator to the frequency of the input signal. So please try to understand. It is the locking of the frequency. So locking of the frequency or signal we can say. So basically signal means the frequency. Okay. So this is the locking of the time-based generator frequency of the time-based generator and the frequency of input signal so that the stationary display of wave pattern can be seen on the CRO screen. Okay. So it can be achieved by trigger circuit that already we have discussed. Then in trigger method, when input signal is fed to the Y plate, it is amplified and fed in two directions, that is trigger circuit and delay line. So that I already mentioned. If the trigger circuit which has been connected with the delay line, so they should be in a sync, means they should synchronize. Then and only we can say that entire synchronization has been done. Okay. So delay line delays the signal before it is further amplified to fed to the Y plate. Hello. Please keep your signals on mute. Okay. Your microphones, speakers, and okay. So just to summarize once again, so CRO, this is a block diagram of CRO. So once the question will come, so it may be asked for say 5 to 6 marks. So you should have to draw the diagram properly, and then what in the diagram, what are the blocks that we have mentioned that you have to elaborate it properly. So first of all, you will start with the CRT. Then what is the role of CRT in very short manner. Don't go in a very much details of the CRT right now here. So when you are writing about the block diagram of CRO, so just CRT, it is used to generate the electron beam, and it focuses and it accelerates. Okay, and acceleration is toward the fluorescent screen. So that much you have to write down, and then after that, this electron beam which is passing through the deflecting system, so that we can deflect the electron beam toward the horizontal or vertical direction. So that much means 2 to 3 lines that we expect about the CRT in block diagram. Okay, then you start with the one by one block, like you can start with the vertical amplifier. If the input signal is been given to the Y input, then what will happen? Then you can explain about the horizontal amplifier, because the role played by the vertical and the horizontal amplifier, because it consists of both the terms, that is voltage amplifier. So that's why you can explain both the terms simultaneously, and then you can come to the time based circuit, then trigger circuit, and then delay line, and HT and LT that you can highlight separately, because HT is a high tension supply that is particularly given to the CRT. So in CRT, where it is assigned, that you can mention, as already I mentioned about, it has been given to the anodes, and then LT, that is for the electronic circuitry. Okay. Hello. So this is about the CRO, that is cathode ray oscilloscope. Okay. So in this way, you have to explain each and every part properly in your write up. Okay, and all this material, now I'm going to form the Google Classroom. So that means I can be able to invite all of you in a Google Classroom, so that we can be able to share the entire material, so that you can start your preparations for this the unit that we are completed. Okay, so even some numerical bank also we have, the question bank, the presentations, some video lectures are also available with us, so that also we can be able to share. Okay, now the last one, that is electron microscope. So electron microscope, as you can see, the chapter is totally based on this electron, that is charged particle. So that's why this topic which is involved here, the electron microscope. So what is the main purpose of this electron microscope? So basically, this electron microscope which is used as a scanning electron microscope, SEM, the scanning. So scanning means what? So if you have some microscopic image means objects, and if you want to develop its image, the microscopic object image, because we cannot be able to see these microscopic objects with the naked eye, or even the normal this you can say the magnifying lens, that cannot be able to give a proper answer to your, or the magnification. So that's why the electron microscope, which plays a major role for the magnification, means you can magnify up to say 10,000 to 20,000 miss magnification level. So that much magnification can be possible with the help of this electron microscope. So particularly this electron microscope, which is used in a research laboratories as a scanning electron microscope, or maybe say in short it is called the SEM, or another the enhanced version is a TEM, that is transmission electron microscope, TEM. So and this is the diagram that we have, is a basic diagram of electron microscope. So what does it consist of? So first part of this is the electron gun. So already you are familiar with this electron gun. So from this electron gun, the beam of electron which has been coming, so this beam of electron which has been incident on a surface of anode. So anode which is in a means like a disc structure. So that means from this or disc, or you can say the lens sort. So that means the beam which has been coming, it should be converted into the parallel form. So the arrangement is made in such a way so that the beam of electron which has been coming through the electron gun, it will incident on this anode sort of lens, and that we can say as a condensing lens, and from this the lens, the beam which will come in the form of a parallel, and then it has been passing through the structure of magnetic lens. Okay, so then from this magnetic lens, ultimately we can see it start from one point and lastly end at the point. So it is called the point to point. Okay, so point to point means it starts from the electron gun, it starts from point and it end at the point. So different stages are there. So these stages are, one is electron gun, then there is a electron beam, then anode, then magnetic lens, and then the backscattered electron detector. So that means it can detect and it can suppress the backscattering also. And then there is a secondary electron detector. If there is any emission of the secondary electrons, so that means that can be detected through a particular detector. And then the specimen is placed on a stage. So there is a stage on which the specimen has been placed. So or specimen can anything. If you want to test a powder sample, whether that powder sample, what is the size of a particular particle inside this powder sample. So you can be able to identify the particle size, or you can say the grain size. It is also particularly, if I use a research language, so grain size determination or microscopical analysis. So all these type of analysis can be done with the help of this electron microscope. So particularly electron, which is a part of this unit, so that's why this topic has been involved. So we expect uh, there may be a question, application based question can be asked based upon the electron microscope, ki how or why it is to be involved in this particular chapter. So as electron, which is a charged particle, so how the electron can be used to collimate as well as to focus the beam of electron, and then how we can be able to get the magnified image. So for this particular topic has been involved. So what are the different parts of the electron microscope that is mentioned here? You can see here. Yes, I will read out here. So electron microscope is in the form of tall vacuum column which is vertically mounted, and it has the following component. So ultimately this entire assembly which is inside a vacuum, you can be able to see this entire assembly which has been placed inside one chamber, and it has been vacuumed. So that means there should not be any effect of outer contaminations. Okay, so it consists of the electron gun. So electron gun is heated tungsten filament which generate the electron. So as everyone know, it has a filament, and once the filament get heated, so it has a cathode, and then there is a grid terminal. So basic purpose of the electron gun is to generate the beam of electrons. Okay, so then electromagnetic lens. So electromagnetic lens means the condensing lens. So the focus the electron beam on a specimen. So this condensing, so that means the beam can condense and it should focus on a specimen where it is to be tested. Okay, so the second condensing lens forms an electron into a thin tight beam, and the electron beam coming out from the specimen passes down to the second magnetic coils called as the objective lens. So in the diagram you can say there are the two lenses which has been, so one is playing a role of condensing, another is the objective lens. So that means high power and forms the intermediate magnified image. So here the magnification job which is to be done with the help of say this magnetic lens. Okay, so whatever, so the specimen it is to be catched through this magnetic lens, and the magnification is been done, and that magnification which we can be able to visualize through this particular detector. So the third set of magnetic lens called as the projector, that is ocular lens, produces the final further image, the magnified image, and each of these lenses act as a image magnifier of all, maintaining its incredible level of detail and resolution. So all these stages that plays a equal role, so that means you can be able to get the proper magnified image through a particular direction. So this is what the role of the electron microscope. So its applications are like advantages, you can say. Advantages is very high magnification. So that is the main part of this. Ki very high means, as I mentioned, ki you can be able to get up to say 10,000 to 20,000 times magnification. Means a small tiny particle of the order of, even right now the age is nano. So the nanoparticles also we can be able to visualize through this means electron microscope. So electron microscope means if you can be able to develop the image of this in a transmission electron microscope, so you can be able to see this pattern, whether the pattern in which form. So that form also, even the nature of the crystal, so crystalline nature, so or polycrystalline, or it may be in a maybe amorphous. So this nature of this powder samples can also be determined through this particular microscope. Then incredible high resolution. So resolution, it means if it carries some characteristic spectra, so that overlapping of these characteristic spectra can be separate out, so that we call as a resolution. Then material rarely distorted by preparation. So this is one of the advantage of this particular. rarely distorted. Means sometimes what happen ki when you are taking any observation, so during the observation sometimes the material which we are placed in a on a specimen stage, so it becomes distorted also. So that distortion should not be happen. So that care is already been taken in this particular setup. And then next advantage is it is possible to investigate a greater depth of field. So as I mentioned, this particular setup which is means particularly used for the research purpose. Okay, research, so where the greater depth of field means wherever a nano size particle is to be identified, so where this kind of research work is going on, so we use this thing. And then diverse applications, so naturally it has a very wide application in variety of fields. Maybe if you are working in a medical science, so variety of specimens are there. If you are working with say means or maybe any sort of application, industry applications are also been there. So diverse applications, that's why it is mentioned. Or you can say the engineering applications in a very diversified forms. Okay, so this is what about the unit number 1. If you have any questions, then you can be able to raise. And then I have some one video. I think we can be able to play that video. I'll just show you the video. Are you able to are you able to see this video?
Yes, sir. Yes, sir.
Is it audible to you?
Yes, sir. Yes.
Okay, so you can see such type of videos are also available with us. So that means whosoever who has missed any sort of say topic, so that student also can be able to cover. Okay, just take a 2 minute. So that means you will familiar.
Hello, excuse me, sir.
Yes,
Sir, that video is playing. I am not able to hear the sound. It's not
video.
audible.
Only I am giving a sample here. I am going to upload this video on a Google Classroom so that everyone can get access to this video also. Okay. So
Okay.
I'm going to close this video right now. Okay.
Okay. Okay.
Yeah. Now I'm going to show you the numerical the numericals that also I prepared in a PowerPoint presentation form. So whosoever has missed this numericals, so they can also go through this PowerPoint. So that means this you can have a recap of all these things. So these are the numericals on electron ballasty. So already these numericals that we have covered. So if somebody who has missed this numericals, so you can be able to refer this PowerPoint presentation so that we can be able to solve these numericals also. Here, what I did, one numerical I mentioned here with the answers and substitution, all these things, and then another numerical I kept blank. So that means you can be able to solve that numerical. Maybe we had covered that numerical in the class also. So like this, say problem number one I have solved here. Then problem number two I have given as the assignment. So that means you can be able to try by your own, and you could be able to get the answer also. So likewise, the sheet has been prepared. So here is the problem number three. So hopefully all these numerical that we have solved in the class.
Sir, how do we get these new PDFs?
Through Google Classroom. So I'm going to invite you on a Google Classroom. Today maybe I will form the Google Classroom. Okay. Hello.
Okay, sir.
Hello.
Yes, sir.
Okay, sir.
So I'm going to form the Google Classroom, and through this Google Classroom, I will invite you all because I have your all email IDs. Okay, so your personal email IDs are there. Still, your Risoni email IDs are not been formed. So till then, we can use your personal IDs. So please check your email IDs personal. Okay, I'm going to share that link of this Google Classroom so that you can be able to join all Google Classroom. So that means we can. So this will be applicable for all subject also. Means every subject, the course material, even the question bank, numerical bank that we can be able to share on this Google Classroom. Okay.
Okay, sir.
Yeah. Yes. Maybe this numerical also we have solved. So please go through these numerical sheets also. So that means you can be able to solve these things. Okay. This is one numerical may not be we have solved this one, so we'll read out and then we'll try to understand what is to be asked here. Please see here the problem number 8, which is given here. The electron accelerated by a potential difference of 200 volts enter in a electric field at an angle of 60 degree. So here the electron accelerated by a potential difference of 200 volts. Okay, so accelerating potential which is given is 200 volts, which enters in an electric field at an angle of 60 degrees. So angle of incidence that we are denoted either as I mentioned, it is not mandatory you can denote it by say theta 1 or theta 2. You can denote it by I or R also. So it doesn't matter. So whichever the notification means you are using, so please try to mention that in your write up also. Suppose here I mentioned by say I, so you can mention by say I also, no problem. If you denote it by say theta 1, so you can mention theta 1 as an angle of incidence as 60 degree, right? Okay. So here the angle of incidence which is given with the normal to the interface of the higher electric field region. So where due to the electrostatic focusing effect, so it makes an angle of 45 degree with the normal to the interface of these two regions. So your angle which makes with the normal, so that is a refracting angle R which is given 45 degree, and then find the potential difference between the two regions. So that is to be asked here. So simply we have the two angles which are given, angle of incidence and the angle of refraction, and then the potential V1 which has been accelerating from, because as we have to understand key electron is accelerated by a potential and it is entering from the angle of incidence, so that's why it is mentioned as V1. So V1 which is 200 volts which is given, and then you have the equation of Beth's law, that is sin I by sin R, or you can say sin theta 1 by sin theta 2, which is under root of V2 by V1. So simply whatever the terms are given, so based upon that you can find out the potential, that is say V2 comes out to say 300 volts. Okay, so the potential difference is 100 volt. Okay, between the two regions that has been formed. So in this way you can be able to solve the numerical based upon the Beth's law also. Okay, and then there's one more assignment numerical on the same platform I have given, only the values has been changed. So you can be able to try this kind of numerical, miss all type of sample numericals are been given in this PPT. So that means you will be familiar and you can be able to try some assignment numericals also. Okay. So then this is about the numerical. Then I will just show you the question banks that I have. So that means we can summarize the entire chapter of or unit of this electron ballistic and optics. Yes. So are you able to see this questions? Is it visible
No.
Yes,
Yes,
sir.
sir.
now?
Yes, sir.
Now I
Yes, sir.
magnified.
Yes.
Okay. So here you can see this is a working sheet. So that means you can be able to prepare for your practical labs also. Wherever the Viva questions has been asked, like basic questions, ki what is the electric charge? Then what is the electric field? Then what are the electric lines of forces? What is electric potential? Then what is homogeneous electric field? Define equipotential surface. So these are the basic terms that you should be able to know, because what is electric charge? So particular electric charge means what? So as we have started the chapter with this point, ki what is electric charge? So particular charges like say electron, proton, or maybe some ions of nuclei. So if these charges means these particles they possess certain amount of charges, it may be positive or it may be a negative. So that particular charges we can the particles we can call as a electric charge. Okay. So in this way means you have to mention properly. And then what is electric field? So you can have an equation of electric field, that is E equals to V by D. So you can elaborate based upon the electric field, then how it can be represented. So electric lines of forces, so that also you can be able to mention. Then what is electric potential? Then homogeneous it means your uniform electric field. Homogeneous is the same word that is for the uniform. Okay. So uniform electric field, so what is the representation of the uniform electric or the homogeneous electric field? So that you, so please try to differentiate between the define and the what. So what means what is expected here, ki you should elaborate something. Okay. Don't write a single line ki okay this is done. Okay. So you should have to elaborate your answer properly. Here is define equipotential. So definition of equipotential. So equipotential it means a particular surface from which we can be able to differentiate between the two potential. One can be a V1, another can be a V2. So in this way, and the potential value is abruptly changing from one region to the another region. So that could be a definition of the equipotential surface. So likewise, there are the different question bank which we have prepared. So maybe some of the question may not be your part, but we will try to delete that, because that part is in earlier syllabus we have kept. So we need to modify. So by today itself we will modify this question bank also, and we will circulate on your this Google Classroom. So another question like here, show the velocity acquired by the electron in uniform electrostatic field is proportional to the square root of potential difference through which the electron is accelerated. So please read the question carefully and what is to be asked. So such type of question can be asked for say 5 marks. Key show that the velocity acquired by an electron in a uniform electrostatic field is proportional to the square root. So what you have to answer here, V is proportional to, means the formula is V equals to under root of twice EV by M. So up to that you need to solve, and then and only you can be able to prove this answer. Okay. Similarly here, what is question number 3 is that is what is electron volt, and express it in joule. So what is electron volt? So electron volt basically is called as the smallest unit of energy. So smallest unit of energy can be written as 1 electron volt, which is 1.6 into 10 to the power minus 19 joules. So express it in joules. So that's that answer we have. So in this way you have to write. Then show that an electron moving with a uniform velocity follows a parabolic path in transverse uniform field. So it's again a straightforward question. Is show that an electron is moving. So what you have to prove here? Ki y equal to kx square. So that equation we should get then and only we can say that it follows the parabolic path. Okay, so in this way, so this also be a question for say 5 marks. Then time, and this is not in your syllabus right now, so this part is omitted. This range, transit, and all this thing, this question number 5, 6, 7 is not been related. Then comes to question number 8. What is Lorentz force? And show that a charge particle cannot acquire an additional energy when it travels through the magnetic field. Or magnetic field changes the velocity of charge particle, but not its speed. Explain. So this thing that you can be able to explain with the help of, as I mentioned in one of the slide here, what is Lorentz force? So force generated or force experienced due to the magnetic field, and then how it can be generated. So for that the laws are also been mentioned, so that you can be able to elaborate with a particular diagram also. Okay, then trajectory, discuss the trajectory of a charged particle in uniform velocity. So these are the different cases which we have mentioned here in this particular question. Then question number 10 is not applicable to you. And explain why this 11 is also not 12 deflected, not then 13, describe what cross field configuration. So cross field basically is your the velocity selector, the cross field configuration. So what do you mean? So what do you mean means here you have to elaborate with a particular diagram. So wherever the diagram is mandatory, you have to draw the diagram, label it properly, and then start answering. Don't write in a vague manner. Okay. Then 15 number, describe the path of electron of mass m and the charge q moving with a velocity v. So here only the path has been asked. You can see here the part A is uniform magnetic field and the uniform electrostatic field. So you only describe, you have to describe the path. So don't only draw simple, so you have to describe it properly. This is a path which is to be followed in a uniform magnetic field. Okay, and uniform electrostatic field. And here condition is also mentioned. You can see here both the fields are applied perpendicular to the direction of motion of the particle. Okay, so underline word is your applied perpendicular. So in both the cases means, in first case you will get a circular path, and in second case you will get the parabolic path. Okay, so in this way the questions can be asked in a different manners also, so you have to catch the proper underline words. Then 16, 17, 18 is not applicable to you. 18 then comes to what are the main parts of CRT. 21 is also there, and 20 discuss the refraction of electron beam across the boundary separating the two equipotential regions. So you can see the question is asked, it is not been asked like explain the Betz law so that you can easily catch. It is asked like say discuss refraction of electron beam across. So refraction of electron beam is nothing but your Betz law. Please try to understand. So that means you can be able to answer the question, because knowing the question is very important. You have to read the question twice or thrice and understand it what is to be asked, then you can be able to start writing. Okay, then comes to question number 21 here. Explain the working of electrostatic electron lens. So working, it means again you have to draw the diagram, consider the two cylindrical structures, apply the electric field, then electric field direct from your higher potential to lower potential, then draw the equipotential in the form of lens structure, and then incident the beam of electrons. So likewise you have to write also in that manner. And then 22 is what are the main parts of CRT, then describe the function of neat figures. So as already we have discussed every part of the CRT. So what is the importance of crossover point? So crossover or the focal point is the same one. Okay, the crossover or focal point is same. What are the voltages and functions of three anodes and grid? So these are the things that can be asked in a separate manner also. Okay, then draw a block diagram of CRO, explain the function of various blocks of CRO. Okay, so in this way, then remaining questions which is not applicable because that can be asked in your practical lab. Okay, so this is what about the accelerator and all these things which is not in your syllabus. So here is the question bank that is available with us. So you can see the every sort of material which is available with us. So we are going to share on this Google Classroom. So please join once I will share the link of that Google Classroom, so that you can be able to even your TAE submissions also we are going to take on the Google Classroom. Okay. So once you will get the notice. So after getting notice, you have to start preparing your own. So and please try to understand ki you are going to participate in one of the competition also based on this TA. So whosoever is been selected, so they will get the prizes also in addition to your TA marks. Okay. So please try to be active and don't copy to one another. So that means you should be means your this poster should be a creative one. Okay. So with this, I expect that this unit has been completed. So from next lecture, we are going to start with the unit number 2, that is optics. Okay. So if you have any sort of say query, you can be able to send on my mail also, or you can be able to write in a chat box also. So that means we can be able to take in a next lecture. Okay. So thank you. Thank you. Here we will stop. Thank you.
Okay, sir. Thank you, sir.
Okay.